Welcome to the story of the alum, part 2, 2 weeks after synthesis. So the alum crystals have been growing, and they have been mostly forming at the bottom of the vial, creating mini droplets coating the surface. And the solution has evaporated a lot from the first video, and some environmental factors that can be contributing to this is that the air conditioning unit is on the entire day in my room, and it produces wind and ventilation, so this may promote the evaporation of the solution. Also, since it's at a colder temperature and the vial was placed near the window, the colder temperature makes the crystals catch impurities as it grows, so it disrupts the crystal patterns. So instead of growing one big crystals, many little crystals coat the bottom of the vial, and so the rate of growth could be smaller because of that, in addition to catching more impurities and forming mini crystals instead of one big healthy crystal.
To first calculate the theoretical yield, we will use our given equation, our given chemical reaction, aluminum plus potassium hydroxide plus sulfuric acid plus water plus hydrogen yields hydrogen gas, and our hydrogen salt, the alum. To do that, we will first balance out the given reaction to get the right relationship between the stoichiometric coefficients between the reactants and the products. So we will have the relationship between 1 salt and then 12 hydrogen to 12 water molecules will be maintained. Now we need to figure out which one of these reactants will limit the reaction. And to do that, I have listed a table with the molar masses of our reactants, so we can figure out how many moles of the product which each of these produce. We can outright determine that our limiting reagent is the aluminum, since it's the smallest quantity. It's the reagent that will produce the least quantity of our product. Now we need to determine how much of our product would be produced to find our theoretical. (17.58 grams). Then calculating our actual yield. We recorded that we received 9.54 grams from our synthesis. And so our percent yield is equal to actual over theoretical times 100%, is equal to 9.54 grams over 17.8 grams.
54.26%. So as calculated, the percent yield was about 54%, and this was not exactly 100%, and this may be due to some random errors. Firstly, the vacuum filtration had some little pieces of alum caught in both the Buchner funnel and in the beaker and in the filter paper. And even though we rinsed it out with ethyl alcohol, we rinsed both the beaker, the funnel, and the paper as much as we could, there could have been some little pieces of alum left behind. It's also, reactions could have been incomplete, and the reactants weren't fully converted to alum. For instance, when the sulfuric acid was added and the aluminum hydroxide precipitated out, the sulfuric acid could have reacted incompletely instead of completely, and not forming the alum crystal. And also, the ice bath that was used to precipitate the alum could have been at a higher temperature than necessary to precipitate all of the alum. So maybe if we had spent more time in the ice bath, or having the ice bath at a colder temperature, we would have precipitated more alum. Another detail is that the aluminum foil sheet is not pure aluminum. It could have contained impurities as well as metals and other quantities, but that we still measured it as 1 gram. So it could have been 1 gram of other things, of other kinds of metals and of other impurities that we didn't factor into our amount that we used to calculate our theoretical yield. That's it for today. Stay tuned for the next episode.